Welcome, I'm Phil Wade, Managing Director of Datgel. In this video, I'm going to give you a brief introduction in how to initially start to use the DGD tool and the CPT tool. So the first thing you'll do is download the full version package, which is this for the CPT tool, and then install the program. Then you also need to do a similar thing for the DGD tool. You download the DGD tool Pro package and run the setup exe file and run through let the installer finish. Now in each of these packages they have a documentation directory where we have a user guide and a GINT files folder where we have the example GINT files. Now in this exercise today, I'm going to be using a compiled library and project where I have merged the CPT tool into the DGD tool Pro library and project. So I'm going to open up GINT now because I've already installed the program. You see I double clicked on the library, that's one way to open, or if you just open GINT from the desktop shortcut, you'll have to select the correct library when you open. So I'll point that out in a second. So if you haven't done so, by double clicking on the library, you need to go to File, Change Library and select the correct library. And then you would need to go to Open Project and open up the project that we want to work with. So this is very important. You've got to open the correct library and the correct project. Then we can see here in the DGD tool documentation, we have the DGD tool user guide. Let's open that up. Let's just see here. Well, we'll just use the default. Okay, so if we just scroll down a bit, we can get to the basic configuration. You should read through the DGD tool user guide and refer to some of these issues. Now what's also very important at the beginning is we set up the system properties correctly. So that's discussed here. And then, we're going to make if you need to make a new project, it's described here and carry on. So I won't be totally saying the whole user guide here. The CPT tool has a similar issue, but to start with, I will select the system properties and point out that we can configure these. I should check this box, so I'll configure this for this example. And we'll leave the last three alone. 2013, this is exactly what's in the book. Check that, check, make this 9. Don't need the rest. Okay, so I have already activated the DGD tool. We do that by going to licensing. I'm running a network license. If I click next here, this is what you would see if you select the first option when you come to that form. And if you're running a single user hardware key, so you enter the license number and serial number here. Now you may have a single user hardware key that has both the DGD tool and the CPT tool on it. Or you may have two separate keys, single user keys, or you may have, but that's uncommon, right? The more common scenario would be that the DGD tool is always shipped with a network license hardware key, or almost always. And that under the DGD tool concept, you would be then using the network hardware key option here. And you would need to set up a license server program and computer to host that, and you plug the network key in there. But today I've already configured that. You can see it here, it's in use. I already entered this data here, just some dummy data, it doesn't really get used. Cancel that, so it's already running. Now the same for the CPT tool. Again, you got licensing for the CPT tool. Now when you see the splash screen, that means the license is kicking off. It's occupying the license. If you have a network license, then that is when it starts to use it. Again, here we have the network license and the serial number for if I was using a single user key, that would be where it would enter it. So I would enter it and then click the validate, same for the network key. The license server is the computer hosting the key. So you just cancel that. So you'd only have to do that once when you first install. It's also possible to copy these things around. Say for example, if we go to C drive program data, so you might have to enable that Datgel. It's possible to configure those settings and then copy these things around that I'm highlighting, all of those actually, and that right there, they're the important ones. You can forget the other ones, and so they control the license configuration like that you just saw, so it saves you having to redo it on multiple computers. Okay, so we have the right library, we have the right project, we've activated the license. We can check the license is activated by clicking some of these add-in commands like the data import tool for the CPT tool, right? It wouldn't load if it wasn't licensed. Actually, the DGD tool also has the import tool, just it has different options in the list. Some are the same. Right, then we will look at the database first of all, where things are a little bit. So the project table stores the project information. One thing we should consider before we progress on is setting some of the defaults, right? So for you to log to British Standard, you should choose BSI. If you want to log to ASTM, you choose ASTM. You can see the various options here. If you want to work to different AGS formats, like have different lists in the thing, so because they are different, definitely, then you can select the appropriate one here. This is quite new, some of these. We've got more options around SPTs, how do you refuse, what to do with the N value when it refuses, like how do you report it, like, so if it's going to be N is greater than 50 or just nothing, or you want to report your lengths in millimeters or meters, centimeters, they're there. Some unit weights for these are used by the SPT calculations, those options. If you want to show the graphic on the log or some other options, you want the watermark, like it's a diagonal sort of text behind your log, they're here. So this is where we can configure some of the options. And the best thing to do if you know you want to do something regularly on all your projects is to set the default value. And then once you've configured everything, you go Tools, Make Data Template to save it for future use. So then you can overwrite your data template. Just cancel that. I didn't mean to change the height. Colors. You see there are different cell colors, right? So the blue is output options. Just controls what's going to print on the report, but it's not truly useful data. Brown is data that's used by calculations, or it actually uses serious engineering use. Purple is more about AGS format. You'll see later there's green and brown green. Green means it's calculated. Browny green means it's could be calculated, could be entered. You can override some of these options on the point table as well. The point options table. Now on the project options, I had to put these here. I'd rather have it on the project options table, but on the project table we have to have these default N values. So if you're doing British Standard, they both should be 75. If you're doing ASTM or or Australian, then you just have those as 150 and leave this blank. I'll just leave it by default as British Standard for now. So one would enter, the standard information like company name and client name, I should say, project number, so on, elevation datums. And you can control what's visible using this drop-down list. So you can see on the left, there's quite a few options in the tree diagram. Say we want to just make it just logging data, or logging and CPT data, but no lab testing perhaps. Click on this, and many of the tables disappear. So that's part of the DGD tool. So the lab tables and monitoring tables, they mostly have gone. If you want to change it back, you just go back to project and change the option, and then the code runs on leaving tables, so it's not instantly on change or on save, so you have to leave the table. Alright, then one would enter the borehole data, so we're going to look at this offshore borehole as an example. You got the borehole type, you've got the coordinates, the elevation, which is like minus because of the seabed. The reference is normally the seabed. Different options there. Sometimes you want to control how many meters per page. You would enter that in here as an override, but each report has its own default. Sometimes you want to split between soil and rock, so not in the case of an offshore log, but say in the case of a normal onshore borehole, you might go from soil to rock coring, and then you want to have different logs presenting that data. You would put the break depth here. There are other options that we won't dwell on. These are calculated. This is the brownie green field that I referred to before, where it could be entered or changed or calculated. Now using our offshore borehole as an example, have samples, so you'd enter the sample data. Now often for most boreholes you would first go to the coring table and the SPT table, and then it would pre-calculate some data that would pop up here. But with an offshore hole you don't unlikely to have those types of data, so you just come straight here and enter the information. You see down the bottom we have things like PPs, tor veins, hand veins. Also, if you scroll over a little bit, you can see it's calculating the percentage of fines and sand and gravel if there were any. Some other things, elevations and total stress and effective stress based on those unit weights and groundwater levels that are on the options table. Soil descriptions, one would enter it here. You've got drop-down lists with different graphics. Geology units, you can select those and make new ones. Things like the geology units are in the list group here, so you can come down here, click on geology unit, you'll see that they're in the list. You can also change the area name, plant name, tester name, all the things that really change between projects are listed here. If they were consistent between projects, then they should be in the library, but that different companies have different processes, right? Alright, then you can choose to use the component description tables. So you could use the Australian ASTM component description table or the British standard. I think if we go here, we have some example data for that. British standard one, have to jump to the BS example. Alright, that's the other option instead of entering data into the description field. We have drilling, so you've got drilling methods, casing diameters, and so on. In situ boreholes, we have SPTs, you've got in situ vein data, in situ pocket ventrometer and tor vein. I think the rest is not that applicable. Rock coring, there's obviously rock coring data. If I change to this offshore hole, it might more consistent. I don't think it has any rock because it's all through soil. Now you may, obviously not offshore, but you could have other onshore. You could have some of these other tests like DCP and so on, permeability. Now I'm going to re-enable the lab testing so we can see everything. So these lists that show and hide things can be configured. They're in a library table. You can read the DGD tool user guide to understand where to go for that. So if we jump to the moisture content table, we've got some moisture contents, density table, Atterberg, and yes, we do have calculations for all of these classification tests. That's an additional product. It's the lab and in situ tool. So it can be quite efficient to do all of that within the GINT interface and calculate these things. Most of these classification tests, yes, moisture, density, Atterberg sieve, hydrometer, particle density, they do have calculations available. Now if you have results for say odometer, it goes here. We don't have calculations available for that at the moment. Direct shear, we do have some for this if you wanted to use it. Triaxial, you've got effective triaxial and total triaxial. We do not currently have calculations available, but there are places for all the results. And there are some. All of these tests have some summary reports, or many of them have summary reports in the DGD tool. Alright, so you enter the data. Now you might go, oh, I'm a bit confused. What do I have to enter? What's useful? Well, you could click on the graphical data input view. And once it loads, I'll change the report to the offshore bore log. Now the logo we're going to see is the Datgel logo. So in this library I'm using now, I have not merged the logo in yet. But by default, if you Datgel configures your library for you, we would set up an office, and on the project table there's an office field, and that controls the logo. So I'm going to change now to these two offshore logs. I'll select the first one. So the first one's more a detailed log, the second one's more a summary log. Now it's going to load again. Okay, now if I zoom, now there's a problem here with the page sizes. I haven't assigned the correct printer to the report, so seeing this is an A3 report, it's getting cut off. It's only going, well, it's jumping to the A4 or letter size page. If I just zoom in near the top, so if we click on different parts of the page, it brings up the tables that are related to that. So the strata main table primarily is getting used there. The sample table primarily is getting used there, or only getting used. The CPT table, I guess, is in this area. So you can have multiple strokes in the CPT table. We'll talk about importing that later. Material description. So I think it's coming out of here. Just drag this over. Click on this graph area, and we should get a number of tables, because obviously there's many different sources for the unbearing shear strength. The NK, this stuff comes from the CPT tool, and the design line, that's in here. Submerged unit weight, so that's coming out of this field here. Yeah, that's interesting. It's coming out of that's what's actually getting printed there, the 2. So just don't have any data in the unit weight field. It's the density that seems to have data in this example. Obviously that is wrong, because you're not going to have densities that are 6, right? So actually this data should all be on the next column. Why don't we change it now? So if I click save, we should see a lot more data plotting. There we go. It's better. And then we have the liquid limit, moisture content, PI, blah, so on. So that's out of these tables here. Alright, now actually the PI would calculate, again, if I click save here, it might just do it. Oh, it's there, the PI, sorry. It already is there. So, alright, so that's the idea. So we're sort of editing and previewing the data there at the same time. That's the graphical data input mode. But if we go to output, little bug here, that's just GINT, but by going to output it'll refresh it. Pick our example borehole, export to PDF, just do it to my temp folder here. So part of the problem here is I don't have a good default PDF viewer on this virtual machine that I'm running. So I'm going to have to browse to that folder manually and open it when it's finished. Normally it would just open by checking that box. Did I not click? Anyway, I thought I was trying to click export to PDF, but in the end, I didn't actually do it, did I? I clicked preview. That's my mistake. Anyway, you can see this borehole goes on for 5 pages. It terminates here. Now, if you don't want the text like that, you can make it appear on top by checking a box on the point table in that cyan colored fields. We looked at it. It's right next to where the depth log page field is. Now we should fix the page size. So to do that, we go to report design to permanently fix it. File, assign, not that one. File, set printer for reports, and if I select a printer that has, well, part of the problem on this computer is I don't have a printer that can print to A3. So I may have to close Gint and open it, but we can check in a minute. Okay, there it is. That's what I need. So mark all, okay. Then this printer does support A3. I may have to set the page size in a second. Alright, it was already A3, so I didn't really need to do that. Alright, so now if we previewed and print, it would print properly. Alright, so we also have the offshore borehole 2, which is more a summary report. So I won't print that. We'll now progress on to the CPT tool. So in this example, we'll import some multiple strokes for CPTs. So let me review where that data is. So in the package that you should have downloaded, we have this example here. I'll just go to the point table. We'll just review that we don't already have this point in the database. It would appear not. We don't have many CPTs. I didn't import any before. Any special ones? No. So to import a CPT, you should refer to the CPT tool user guide, which has the quick start tutorial in there. Will give you a really good introduction. But we're going to do a little bit more complicated example where we're importing from a series of Gorilla files. So I'll just copy that path into here. So I need to browse to those multiple files. Alright, so they're the multiple strokes. We need to select the most relevant correspondence file for this, which is so there's a whole series of different ones for different file formats. We need this one, so it assumes that, I know that because it says ref level, right? It assumes that there's a parameter in the Gorilla files called reference level where you put the start depth of the stroke. Now, Gorilla does not have the sleeve offset applied, so you need to apply, you enter that there, and then upon import we will offset the sleeve data. If you forget to do it, you can fix it later. You need to use the data correction tool to do that. So click execute. So this is going to import into the point ID that's named in the Gorilla file. So you need to ensure that that matches up with the point ID name that you want to have, for your borehole data. Otherwise you'll end up copying things around, which would be a bit tedious. So I guess you'll have to sort of do a little trial and error to get that right the first time. Alright, so at the end of the import, we have the log, the text log, which tells us what was imported. We have 1,050 records in the CPT data, one point table record, 7 strokes. Sounds about right looking at this information. So we click OK. Then we can review the data. Have a look here. This is the point, actually. Now this is wrong. I'll have to come back and update this. It's just that it imported from the first stroke. Go to CPT. See, we have the various strokes, 1 through 7. Goes to 21. So that's what we should put on the point table. I'll just do that now. Basically, I think it will calculate now. You can put the offshore water depth in. I'm going to use the tree diagram in the point parameters. So let's just say the offshore water depth is like 50, but it doesn't affect the calculation. It's just metadata. So if you go back to CPT data, at this point, actually, okay, by putting 50 there, it's now causing all of the strokes to calculate, which is fine. We'll just do it. It's going to use the default settings. Alright, so each stroke will calculate, then only one can update at a time. So you have to wait. Now, you'll find that there's a lot of calculations happening at the moment, which many of them are just irrelevant to what you're doing, like the liquefaction doesn't really apply, and plus some of it doesn't quite work when you've got all these multiple strokes. So that can be turned off by going to the add-in CPT tool, formula tool, and unchecking the boxes for the ones you don't need. I won't actually show you that now. I'll just, but you can look at the user guide to learn about that. Alright, so click close. I think it's jumping to CPT data at the moment, so then we will see the calculated results. So where it calculates the soil behavior types, the underhand shear strength. This is the table with the sort of normal soil parameters. Let's drag this up a bit. So you can change strokes by just clicking on the page here. Now the cone information, I didn't really check that before, that's quite critical. So let's jump back and see. So ELC10, I wonder if that was actually in the database already. It may have been because we have some information already calculating. So ELC, this one. Alright, so I already entered it. Now normally you will have to enter that. And the two things that are most important are the cone area ratio and the cone sleeve offset. If you're doing dissipation test analysis, you also need the cone diameter. The rest I don't think are used. Maybe that's used. Sort of can't recall right now. So enter that before you calculate. Now you can, when we calculated then it did it automatically, and that's because the option is set to do the automatic calculation on the project parameters table. You can also check this box to suppress that, and then alternatively you have to then do a batch calculation. It also do a batch calculation when you go to output, or when you leave input, it will prompt you to do it. So that can be convenient. Now you can select the different soil behavior types here. There's a number of options. Unit weights, I guess in some parts of the world the unit weight of water is not one. It could be a lot more, like seawater could be a lot more heavier than that. So you may want to change it. You can set the NKT values overall for the soil behavior underhand shear strength 1 here. More simplistic approach for underhand shear strength there. So you can see there's a different methods, and each the input parameters or constants for each method are listed here. So this applies for the whole project. Then you can override that. Well, I'll get to that in a minute. We'll just work our way through here. This table allows you to sort of define output options. So that should not be that. I'm going to change the default here. It is actually false. Anyway, it shouldn't be there. The double quote. And maybe just the example data in the project actually, not the default. So you can override some of those settings at the point level here, others here, and you can do it at a depth related level for at a point ID depth related level as well for some things, a limited number of items. We have projects in biology. This is where you can control the scales. So pretty common, you want to set the maximum scale to 40 or 20 if it's really low for cone resistance. This is also total cone resistance. You can do that here. And you may like to set the number of divisions. If it's 20, you might like it to be 4, or probably 4, maybe 5. You can do that there. So I'll make it 20. I'll make that 4. When we print this data in a second, we'll see that. Alright, now let's go to output and we'll preview that CPT data. So that information we just calculated can also print on the offshore borehole log. Why don't we do that first? We'll print the gorilla example, but it'll just, because there's no borehole data as such, it's just the CPTs. Now that reminds me, you probably want to delete the garbage, at the beginning of the stroke. So you literally should go to the data table, the CPT data table, and delete the records. So this is the alright, that was only one page, right? Obviously it goes a bit deeper than that. Now this time I will print a CPT log. So we have all these reports. I start with CPT. Maybe this one. I'm trying to remember which one shows what. I can't. One of them was more a style that offshore companies wanted to display. Now in the download, in the documentation, there is an example PDF of all the reports. So you can, and it has a bookmark showing the report name. So you can look at that and pick the ones you like and then go and print them off for your data. The license system user guide also explains how to use how to license your software. And on that point, mostly we ship inactive hardware keys. So you need to go and activate the key by importing the UPT file, and that's we would have emailed you in our fulfillment email. We give the link to the UPT file. Yeah, this seems to match that other data. So perhaps in this one you don't want to show the pre-drill. And I'll show you one more report. So that one, there's many fixed reports just like that where you don't have options, but the dynamic reports give you the ability to pick what you want to see on the page. So we might like to show normalized cone resistance and Young's modulus and liquefaction factor of safety. If that makes any sense for this data, I don't know. Soil behavior type. Now we got with soil behavior type, right? We have the sort of graph type approaches, which are these ones here. We also have the soil behavior type indexes. So many people seem to like this one, and well, there's other options. I'll show you that. So there's two graph approaches getting calculated, and all of the indexes are calculated at the same time, and you can display the legend down the bottom. So click OK. Alright, so that's what a dynamic log looks like. So I think if we, just point out where you can suppress the stroke, not stroke, but the pre-dual information. So that is here. Make that false. You won't get it. Alright, well, that brings us to the end of this example. Just introduction, so if you have more questions you can contact me by email or phone. Thank you for your attention.